Exponentials. First of all, what we need is a natural base, called the natural base e. Does anyone know? That's an irrational number. It means it goes on forever. Does anyone know what it's approximately equal to? No? 2.71. It appears in a lot of applications like compound interest, engineering applications, like how like a power line hangs. That shape is actually an exponential shape. So it goes on forever. I put a little squiggly equals because I'm rounding it off. Okay, so irrational. That's an irrational number. So we're going to see it later. It's just used a lot in logs. Okay, because it appears a lot in nature. So let's look at function notation first. So far I've been writing all my functions as y equals something. Right? This function, I could have written it with an f of x. What does f of x mean? Nothing different than y. It's just a different way to write y. It means the exact same thing. The only reason they even have invented a function notation is because with word problems and things, it makes it easier. So if you were talking about a cost function, you might say the cost, where x is the number of units and c is the cost in dollars, say. Right? So this is saying, when you look at it, you say this is a cost function that has x's in it. And that's all it means, is that that's the letter that's going to appear over here. Okay? So that becomes extremely important in upper year math after your first year, because we might have a function like this. With two letters in it. Two variables, but they're not two variables. It's still only one variable. A variable means it can change. This is only a one variable. Even though there's a y in it, that's a constant. How do we know that? Because if you look right here, whatever's in the bracket is considered the variable. So that y could be just a constant. It's just fixed, like a 2, a 3, a 5. So that becomes important, not in first year calculus, but in second year calculus. Is we don't just write y equals, because then that makes it confusing. You don't know what the variable is, especially if there's 2, 3, or 4 different letters in the equation. Okay. So function notation. So f of x is the same as y. It's just a different way to write it. So a exponential function is a function of the type where a is a number not equal to 0 or 1, because what's 1 to any power? Just 1. 1 times 1 times 1 times 1 is just 1. 0 to any power is 0. So a is usually greater than 0. So we say a is greater than 0, but not usually equal to 1. So that would be one way to write it. Okay. So what does that mean? 2 to the power x is an exponential function. X to the power 2 is not an exponential function. This is a quadratic. Or we could just say a polynomial. So a polynomial is when it has x to a power n and the number is up here. And an exponential is where the number is the base and this has the variable in it. Exponential, the variable is the base, or polynomial, the variable is the base and the number is the exponent. So those are the difference. Okay? So that's what it is. So what we're going to do first is I'm going to write 3 down. We're going to do a table of values and draw it so you can see what the graph looks like. But we're not going to get into the graph so much like using transformations. We're not going to do that, but we'll draw the graph just using a table of values and knowing what the basic graph looks like. So we are going to be given f of x equals 2 to the x. We're going to make a table of values and plot the points. Okay, we're just going to do that for 3 different examples. So, a table of values. So we're going to put in negative numbers like -2, -1, 0, 1, 2, like that. Okay, so just off to the side, 2 to the power, we're putting the x in, so it would be 2 to the -2. What do you do there? Back to the first class, or first couple classes. What does a negative exponent mean? Is it, no? Yeah, flip it, it's a fraction. So this is 1 over 2 squared. You make it positive when you move it down to the bottom, so that's 1/4. 2 to the -1. That would be 1 over 2 to the 1, which is 1 over 2, 1/2. 0. No? Yeah, anything to the 0 power is 1. 1. It's just 2. 2. 2 squared. 4. Okay, so let's take these 5 points and we will draw the graph. So I went -1, -2, 1 and 2. And our y values are all positive. Do you notice that? And they always will be. Okay, so they're all positive. That's the range. Whenever you plug in a number, it can't make it negative. When you plug in a negative, it makes it a fraction. So it doesn't make it negative. So -2 gave me 1/4. Let's go like this. 1, 2, 3, 4. So 1/4 is really down here. -1 gave me 1/2, a little higher. 0 was 1. 1, 2, 2 is 4. Now we could plot more points, and if you have a calculator, you could even go in between, like you could do plot 1.5. Where do you think that would be? Like in here somewhere? What about 3? What's 3 going to be? 2 to the 3. 8. So 3 is way up here at 8. What about on this side? What if I put like -100? Do I get a negative number? No, I get 1 over 2 to the 100, which is a huge number. 1 divided by like infinity is really, really small, but not quite. So it gets closer and closer to 0, but it doesn't touch. So if it gets closer and closer to something but doesn't touch, what is that line called if it never touches 0? Right, so this actually has an asymptote. So that's what the graph looks like. What if I put 3 to the x? What's going to happen different? The points will be slightly different, but won't the shape just look the same? It'll be 1 over 9 and 1 over 3. What about 3 to the 0? Still 1. It's going to look the same. Is it going to be higher or lower, do you think? A 3. So this is 2 to the x. So 2 to the x, it goes through the point 0, 1, and it has an asymptote here at 0. It looks like that. So this is 2 to the x. What do you think 3 to the x is going to look like? So instead of being 4 when we put a 2 in, if we put a 3 in, or a 2 in, but it was 3 to the x, what would we get? 9. So instead of 4, we're getting 9. So is it going to be higher up? Yeah. But it'll still go through the same point. It's actually going to be lower on this side. That's not a very good graph. I should fix that. It'll be lower on this side because the fractions will be smaller because the bottom will be bigger. A 3 on the bottom is bigger. So what about a 10 to the x? It will be the same except even higher. I should have drawn the 2 down a little lower to make it obvious. What about e to the x? What's e? About 2.7. So that's where 2.7 is between 2 and 3, so it would be in here. Right? The graphs always look the same. They all have one point in common, 0, 1. And it's just they're either higher or lower. But we're not going to move them around. I just want you to know the basic graph because you'll need to know that. Okay, what that basic graph looks like. So that's what the basic graph looks like. All right, so let's do a table of values for this one. I didn't put 1/2 on there. I just said like 2, 3, 4. 1 isn't an exponential, so, but we can have fractions. So let's do a table of value for that. We'll just do the same point because that's enough points to get a graph. So -2, -1, 0, 1, and 2. And we're going to plug them into 1/2 to the power x. So 1/2 to the -2. What does a negative exponent do to a fraction? Flips it. So this will be 2 over 1 to the power 2. 2 over 1 is just 2. 2 squared is 4. 1/2 to the -1. Flips it, makes the exponent positive, and that's just a 2. 1/2 to the 0. Just 1, anything to the 0 power is 1. 1/2 to the 1. Just 1/2. And 1/2 squared. You square the top, 1 squared is 1, and square the bottom. 1/4. Are those not the same numbers we just had? But what's different about it? They're the opposite. So when we draw the graph, it is just the opposite, that it goes this way. So it just is the opposite. The asymptote is still there, but it goes the opposite way. What about this? What's a negative exponent? Flips it. So that would bring it down to the bottom. This would be 1 over 2 to the positive x. Is that the same thing? Power x. 1 to the power x is anything 1 is 1. 1 times 1 times 1. So 1 over 2 to the x. This is the same as 2 to the negative x. So a fraction or a negative exponent actually mean the same thing, and they're flipped. What would make the graph flip down instead of sideways like this one does? What do you think? Think to all our graphing techniques we just did. What makes it flip down? A negative in front. And we can do that. So this graph is that way. This is 2 to the negative x, or a fraction. Okay, that's that way. If we put a negative in front, like that, so 2 to the x, the basic graph is this way. A negative in front is that way. Okay. That's all you need to know for graphing. We're not gonna graph them and move them up and down and around sideways. We're not gonna do any of that. But I just want you to know the basic graph and sort of how it flips if you see different negative signs in different places. So this is our next question. So I gave you an exponential function. It's not just a function itself. We wouldn't be asked to graph something like this. But I'm asking for a few points. So by putting that like 0 in here instead of the x, this is saying take all the x's and replace it with a 0. Take all the x's and replace it with a 1. So these are just asking for points that would be points on the graph. But I want to do this example because there's a negative in front. The exponent has like a 2x, and people sometimes get them messed up. So if we wanted f of 0, you rewrite it, put a 0 in where the x was. Now, what's 2 times 0? 0. So this is minus 4 to the 0 plus 3. Now that minus sign is not in the bracket to the power 0. F of x here is minus and then 4 to the 2x plus 3. That's how it is. It is not like this. Okay, I want you to see the difference. How do you know the difference? This one would have to have a bracket to say that that 2x applies to the negative sign, and this does not have a bracket. If it does not have a bracket, that means just the 4 is to the power 2x, not the negative. So it's more like this. You would evaluate this first and then put a negative in front. Okay, this is, and this is not. So what's 4 to the 0? 1, and we still have a not minus in front. Plus 3 is 2. So f of 0 is 2. And when you see something like this, f of 0 is 2, this is the same as writing a point, 0, 2. So it's just a different way to write a point. And you can always write your points that way if you wanted to. It means the exact same thing. It's just a different way to write it. All right, f of 1 minus 4 times, or to the power 2 times 1 plus 3. 4 squared, 16, and then the minus in front. Okay, the other ones are fractions. And I know you don't like fractions, but they're actually going to work out nice. So what's the next one? No, and that's what I'm saying. Like, you have to, the minus is in front. So you have to do the 4 first. Yeah, so that's, you have to be really careful. That's the whole reason I'm doing this example, because I don't want you doing that by mistake. A negative in front of something doesn't mean that you square it or cube it or anything unless it's in a bracket like that. Okay? So the next one is a half. So minus 4 to the 2 times 1/2 plus 3. What's 2 times a half? 1, because it's 2 over 2, which is 1. So minus 4 to the 1 plus 3. Minus 1. What about negative a half? Minus 4, 2 times negative 1/2 plus 3. 2 times negative 1/2 is negative 1. So this would be negative 1. Now what do we do? And remember that minus sign in front is not really part of the 4. It's like a minus 1 times 4. So that negative exponent makes it a fraction. This is sort of like saying minus 1 times 4 to the negative 1 plus 3. So it would be minus 1 stays on top and the 4 moves to the bottom. So minus 1 over 4. 4 to the power 1, which is 4. Now what do we do to combine these? Common denominator. So multiply that by 4. Minus 1 plus 12 over 4. And the last one of these. So, minus 4, 2 times 1/4 plus 3. What's 2 times 1/4? 2 over 4, which is 1/2. What does 1/2 exponent mean? I heard someone whispering it. Right, square root. But is it minus under the square root? No, because that minus is like in front of the 4. It's not part of the 4. So this is minus square root of 4. So f of 1/4 is 1. Okay, so that's just plugging numbers in. Now what we actually want to do with this stuff, to sort of lead into logs, is we want to solve equations that have an exponential in them. We want to solve for x. That's what this course is all about, solving for x. So first, let's write the powers that I want you to remember, okay? So we want to know the powers of 2. 2, 4, 8, 8 times 2, or 16 times 2. We could go up one more, 128. You can do 2's pretty easy without a calculator, right? Timesing it by 2. Let's say powers of 3. 9 times 3, 27 times 3, and that would be as high as I'd expect, like 4 numbers for 3, 4 numbers for 4, 4 numbers for 5, and 10, it doesn't even matter, all of them, because 10's really easy. Okay. So you need to know these, like as well as you know that, square root of 16 is 4. So you know square root of 25, you know square root of 9. You need to know the powers, okay? So if you see an 81, you have to say that's a power of 3. So you need to be very familiar with these numbers so that if you see one of them, especially in the log section, you know that it's one of the ones that work. Because when you see a square root and you look at what's under the square root and you see a 25, you should say to yourself, I know that works. Or a 36 or a 49, you know those doubles, and when you see the square root of it, you know that it works and you don't have to stop and think about it. So if you see a log that has an 81 in it, you're thinking 3. That's a power of 3. If you're seeing something with 64 in it, 64 actually appears here twice. So does 16, so does 4, right? So you can think 2 or 4. What's the next one in 2s? 256, right? So these are all in here, but. And when you see a 625, you think 5. When you see a number that's not in here, that's when we have to use logs to figure it out or estimate, because it won't work. It'll be in between. So you need to have these memorized well enough that you recognize them. If you see an 81, you know that's a power of 3. Okay, so here's how you solve an exponential equation. This is going to be type 1, the ones that work nice. This is when both sides of the equal sign can be written with a common base. The base is the number at the bottom. So I'll show you what I mean by that. And this is type 1 when it works nice. That's sort of like a square root when you have to take the square root of both sides or the cube root of both sides, and it works nice. That's this type, okay? And then we'll do the ones that don't work nice after. So if I said, for example, 3 to the x equals 81. So what did I say about the powers? Well, we've got them memorized, and 81 is a power of 3. What power of 3 is it? This is 3 to the 1, this is 3 squared, this is 3 cubed, this is 3 to the 4. If you need to figure that out as you go, that's fine. That you recognize that 81 is a power of 3, and you need to know which one. So which one is it? 3 to the 4. So you can write this as 3 to the 4. Now what do you think x is? Yeah. Look at the two equations. How would the two sides of the equal sign be equal? If x was 4, right? If we put a 4 here, wouldn't the two sides be equal? Yeah. So we just say x equals 4, and that's the answer. These are the ones that work nice. I can make these ones that work nice a little more complicated, though. So what would a little more complicated be? 2 to the x plus 1 equals 16. So you see an equation with an exponential in it, and you say, so your question is, can I write both sides with the same base? That's question 1. Remember I talked about the words you need to have in your head? So you say, what? Can 16 be written as the power of 2? Is 16 a power of 2? And which power is it? 2 to the 4. 4 and 4, 15. Yep, 2 to the 4, right? However it is you figure it out, but you recognize that it is a power. So now we can't just read it off, but we would say, for these to be equal, the exponents have to be equal. So x plus 1 would have to equal 4. So x would be 3. So that's one step harder. Now, sometimes we have to rewrite both sides. So, easy enough though. So if I said, for example, 25 to the x is equal to 125 . Now, in this class, we're only doing, it has to be a power of 2, 3, 4, 5, or 10. Okay? Which one is this? 5. 25 is 5 squared, and 125 is 5 cubed. So 25 squared, and there's an x up there, so 2x. That's how that would look. And 125 is 5 cubed. Whoops. Sorry. That's better. 25 is 5 squared, and there's an x up there. And 125 is 5 cubed. Then compare the exponents. So 2x equals 3, so x is 3 over 2. Okay? Easy enough? Ready for a hard one? That's the basics though. That's what you want to do. You make them both the same and then you compare the exponents. If they can't be made the same, that's when we have to use logs. So that's in another section. Okay? So in this section they all work nice. But in real life you won't know if it works nice or not. Meaning on the final exam, I'm not going to separate them by section, so you won't know. You have to know the powers to know if it's going to work or not. So here is, what powers are we thinking automatically now? You have two choices actually, 2 or 4. You can write them both as power of 2, or you can write them both as power of 4. Because 64 is 4. You can look back at the list if you want, if you're not sure. 4 cubed, or you could say 2 to the 6th, either way. Let's do it with 4s. 4 cubed is 64. Now, 4 cubed. What about this? How would that go with that cube? In a bracket, exactly. Because this is 64 to that whole power, so it has to be 4 cubed to the whole power. Now, we can't compare exponents yet because the bases have to be the same, and right now this is a 1/4. How can we write it so that it's a 4? It's on the bottom. If we move it up, this would be 4 to the minus x. 6x plus 3. And now the bases are the same. Okay, so it could have a fraction in it. Move the base up to the top. So now we can compare the exponents. Negative x equals 6x plus 3. Three minutes left. I want to show you this one. We'll put a square root in it. What's a square root as a power? 1/2. So this would be 10 to the half. Can I write this as a 10? 100 is 10 squared, so this would be 10. There's already an x there. So 1/2 equals 2x. How do we solve that? I don't want the 2 in front of the x. Divide both sides by 2. But remember, that's a fraction, so it can actually just move to the bottom. I wouldn't do 1/2 divided by 2. That looks a little more complicated. This would be 1/2 times 2. You can move from the top to the bottom, so 1/4. And I just want to squeeze one more in here. One more to finish the section. All right? So here's the last one. 1 over e cubed equals e to the x minus 2. E's are easy because they already have an e, like there's no powers of e. E squared is just e squared, e cubed. So e's easy. We just need them both to be on the top. So what would we do to this one? E to the minus 3. And then compare the powers. So minus 3 equals x minus 2.